I will talk about the unit 10 of precalculus. That will contain the sequence and the series, arithmetic sequence and series, geometric sequences and series, mathematical induction, and the binomial expansion. Let me talk about sequences and series. Sequence means an ordered list of numbers. Term means each number in the sequence. Infinite sequence is not an endless sequence, but the infinity sequence is the opposite one to the infinite one. Is an endless sequence. The recursive formula is useful formula for a sequence, as the picture on the right. Arithmetic and geometric are the different formulas. The explicit formula is used to find a specific term in the sequence, as the picture at the bottom. Convergent sequence is when through some terms you achieve a final. The divergent sequence is which term never become constant. They will continually increase or decrease, so they are endless. Here is one of two examples for sequence and series. Find a recursive formula for the following sequence. First, find out if it is arithmetic or geometric. After the calculation, we could see they are same. It could be both, I think. So use which one of two formula will be fine. Then A1 is equal to 2 and R or D is 2. We'll put those numbers in the formula, then we got the answer. From the question, we know the A1 is 10, N is 2. Then put all numbers we got into the formula of the question. Then let me talk about arithmetic sequences and series. Arithmetic sequence is an ordered set of numbers that have a common difference between each consecutive term. The common difference is the constant difference between the consecutive terms of an arithmetic sequence. Arithmetic means is the average number of the series. The first difference is the first difference of the sequence, and the second difference is the second difference. Arithmetic series is the sum of the sequence that is arithmetic. Find the next term in the sequence below. As we know, it's an arithmetic sequence and it finds a specific term of the series. So we use the formula on the left side. A1 is equal to negative 6, and the D is negative 1 minus negative 6 equal to 5. Then put those numbers in the formula, then we get the answer is 9. According to the question, we could know A1 equal to 1000, A2 equal to 2000, and A3 equal to 3000. D is 2000 minus 1000 equal to 1000, but this time it's asking for the sum, and we don't know the last term, so we use this formula I write it down below. The n might use 100,000 divided by the 1000. Then we put all the numbers we got, and then got the answers, $505,000. And then we talk about geometric sequences and series. Geometric sequence goes from one term to the next by the always multiplying or dividing by the same value. Common ratio is the amount between each number in a geometric sequence. Geometric mean is the average value of the geometric sequence. Geometric series is a series for which of the ratio of each two consecutive terms is a constant function of the summation index. Find the next term in the sequence below. So it's a specific number, so we use the formula I put under the questions. A1 equal to negative 6 and the D is minus 1 minus -6 equal to 5. Then put those numbers in the formula, then we get the answer minus 48. Find the sum of the first 4 terms of the geometric series. We don't know the last term, so we use this formula that I put on the right side. A1 is 3, n is 4, r is 2, which is 6 divided to 3. If we put all the numbers in the formula, we may get 45. Mathematical induction. Principle of mathematical induction is if an integer 0 belongs to the class f, and f is hereditary, and then even non-negative integer belongs to f. So it's like a category system. The intercept and inductive hypothesis and inductive step is the first step, the particular case, and the next case. Step 1 is usually easy. We use n equal to 1 to prove the truth. Then step 2, assume it is true for n equal to k, so bring the k to the equation. Step 3, bring the k plus 1 into the equation, and we found a portion that is same as the step 2. So we substituted, then expanded and simplified it. At last, we know both sides are equal, which means this equation is true. The steps are the same as the last example, but we want to check is multiple of 2 or not. So on step 2, we need to place 2r on the right side. If it's asked is something a multiple of another number, we may say the number is n, then place nr. So continue it. Unravel the equation, we see the something times 2, 3k plus r times 2. So it's true for the question. So on, we talk about the binomial expansion. Binomial coefficients is the number of ways of picking unordered outcomes from the possibilities. Pascal's triangle is the picture I put on the right. They help us to solve the expansion. The binomial theorem is a quick way of expanding a binomial expression. First, find a and b. A is x, b is y. Have a pattern that is the first term. A will be the exponential of 6 and b of exponential of 0. The second term is exponential of 5, b is the exponential of 1, and then so on. The exponential of a is decreasing, but b is increasing. Like this, we expand the equation. The next step, times the number according to the Pascal's triangle. We see the question's exponential is 6. So we need to times 1, 6, 15, 20, 15, 6, and 1. The order of the series is same as the equation we expand. So like the first term we times 1 and the second term we times the 6. At last we got the answer. The steps are the same as the last one. The only difference is the number need to be times. The exponential is 3, so we need to times 1, 3, 3, and 1. Then we get the answers. And that is all. Thank you for watching and listening.